Hi, I'm recording this video for the ASHRAE 2020 virtual conference. My presentation is entitled GEPIII third place solution, XGBoost and IGBM with weighted post-processing, despite the fact that I didn't use XGBoost but neural network. My name is Xavier Capdepon. I participated as a solo participant in a competition organized on the Kaggle platform using data provided by ASHRAE in 2019. In this presentation, I will basically walk you through the step that I use to generate my final submission in this competition. My name is Xavier Capdepon. I am based in New York in United States. I have a master in engineering from a French engineering school and also a master in corporate finance from Lyon Business School. I am currently looking for a new opportunity in machine learning or data science. I worked in data science and machine learning field since 2015 in various domains. And I previously worked as a structurer and a trader on Wall Street for 8 years before moving to machine learning and data science. I discovered Kaggle in 2015 during a data science bootcamp, and I participated over the year in 24 competitions. So this competition was organized by ASHRAE. 3,600 teams participated in this competition. And the object of this competition is to develop an accurate model to predict the energy usage of some buildings over time. The data come from over 1,000 buildings on a 3-year time frame. The competition was launched in October 2019 and finished in December 2019. So this competition has many particularities. The first is that the training data is only comprised of 1 year, when the testing data is comprised of 2 years. For this competition, the test data, in the test data, the buildings are the same as the training data, which imply some low generalization of the model. So the public leaderboard, which is a temporary leaderboard, was calculated on the first 1.5 years, when the final leaderboard, which is a private LB, was actually built on the last 6 months of this prediction. This is a time series data because the different variables were recorded over time. And in order to constitute a strong and consistent cross-validation, you must use successive periods in your different folds during your cross-validation scheme. And you may use successive period of 3, 4, or 6 months. Another characteristic of this competition is the fact that some Kaggler found out that the target on the test data could be found online. And the sponsor had to make sure at the end that the ranking was actually based on the non-available data to make things fair. It was a regression problem where we were asked to calculate the meter reading on energy consumption. Everything in my solution was built in Python in Jupyter Notebook. Everything was calculated on AWS, most of it on CPU, but one model was using GPU. So unfortunately or fortunately, the key of my solution is actually the cleaning of the data. So some of the cleaning was actually shared through the competition forum. So for example, some time zone needed to be adjusted because some of the data was provided with different time zone referential. so they need to be adjusted in order to make a better prediction. There was some missing temperature data that needed to be interpolated in order to help the model to improve the prediction. And there was some clear outlier in the target vector that needed to be removed in order to make a better prediction. And finally, there was some inconsistency in the non-available data, which have been imputed to 0, and they needed to be removed in order to make some value of the real 0 values. In order to illustrate this point number 4, I can share this graph where in the x-axis you can see the target vector for 2016 for each meter type. In y-axis you have the building IDs. In green, the meter reading, which is the non-zero values, and in blue the meter reading, which are zeros, and the non-available data is in white. You can see that there are some patterns, which means that it's likely that some missing value have been imputed to 0. For example, on the bottom left of the chart, and also these lines that you can see through the different meters at the same time for the same building, which most likely means that they are not 0 values, true 0 values, but they are missing values which have been imputed to 0. And removing them actually helps the model to actually generate better prediction. So the second step after that is to basically generate features in order to help the model to reduce the error on the prediction. One way is to calculate, to build count feature and combination of raw features. I also used time lag on raw features, but only the temperature feature lag were useful to the model. I use also the relative humidity, the field lag temperature, and the model also picked up on the presence of other meters in order to make a better prediction. The feature based on trigonometric transformation of hour, months, and wind direction were actually useful in this particular case. The idea of this kind of transformation is to tell the model that the month of December is really close to November, but also to January, especially when you work with only 1 year of data, and that December is way closer to January than it is from May or June. By reading some research paper, I found out that some horizontal solar exposure could be calculated based on the latitude of the building, and this latitude was basically approximated based on the forum discussion. It actually helped the model slightly. And finally, something that I didn't use in this particular submission, but it can be quite useful, is that the square feet multiplied by the floor count was picked up by the model, which most likely means that the square feet variable was likely the ground floor area and not the total square footage of the building. This is some visualization of some raw features over time. As you can see, some of the features are following some Gaussian curve, which can be good, which are a natural fit for a neural network. After these 2 steps of cleaning data and generating features, there is a step of feature selection, which is the process of deleting useless or poor feature in order to have a better model. This is actually done by looking at the local cross-validation. If you improve, if the model improves with a feature, you should keep it. If it's not improving, you should remove it. It's also using the LOFO method, which has been developed by Grandmaster Kagler. The idea behind it is to see how gain you get in the training data, but also on the validation set. If you can have for features which have been collected over time, you may see a gain much larger in the training data than in the validation data. And you may want to delete that particular feature because it's not actually helpful to the future data. And everything was done using LightGBM model, which is a gradient boosting tree developed by Microsoft. In this particular case, it's extremely fast to run. It's easy to fine-tune, and it can easily output the gain per feature, which is not the case of model like a neural network. So in this competition, in order to remove variance, we can combine different statistical models such as neural network and gradient boosting, but we can also, since the features are contain quite a lot of information, try to diversify the different model by using one single statistic model, such as LightGBM, and inputting in this in LightGBM different combination of features. And this different combination of features will provide diversity to the end model. So in my case, I used 9 models without the leak. These models are 5 LightGBM, 1 CatBoost, 1 East gradient boosting, which is something new on scikit-learn, which is highly overfitting, that I should have removed, but I didn't know at the time that it was overfitting. Some dense neural network, which have a poor result, but are quite helpful in terms of diversity, and a 1D CNN developed in Keras and TensorFlow, which has really promising result. So all this model on the private LB scored between 137 and 128. And for my final prediction, I basically run these 9 models, extract the prediction, and use them as input for a second level model using LightGBM. And I just added to this prediction, I added the original meta type raw feature. And I ended up with a private score of 123, which is basically the 3rd place over 3,600 participants. This is a graph of how to generate my 3rd place solution, which is available on GitHub if you are interested. The entire process takes over 12 hours if everything is run sequentially. And the data cleaning takes between 3 and 4 hours. So since you may not be interested in such a complex model, you could pick one of the level 1 model. I will suggest to take something like a LightGBM model because it is extremely quick and fast to run. The entire process will take not 12 hours, but only 3 to 5 hours. A lot of time is spent on the data cleaning, actually. And the notebook, in the case of the submission without leak 001 LightGBM, the notebook will use 12 of the original features, and the script will also generate on top 20 engineered features in order to score on the private LB 129, which is not that far from my 123 final score. This code is also available on my GitHub. What should I have done to improve even more my submission? Most likely by digging more on cleaning the data would have been helpful. In this particular case, combining neural network with gradient boosting was really helpful. Especially since decision trees are known to badly interpolate out of the original target values. What was promising was the convolutional neural network one dimension in order to leverage this time series data, which followed some natural Gaussian curve. So it was a natural fit for neural network. And also something that I tried to work on, but did not manage to get anything from it, was to try to design some transfer learning using a neural network transformer. The idea is to build a model based on some building where you have a strong prediction and try to transfer the learning to the new building in order to make a stronger prediction. I didn't have any success, but I invite you to look at the Kaggle forum. Some of the other Kaggle, some individual actually had success with that method. So in this competition, we saw that cleaning was essential and key in order to have an optimized solution. Fortunately, unfortunately, the feature engineering and feature selection was not the key, but was part of the process. And something that gave me a hard time was actually the cross-validation, which was inconsistent with the public LB. So I had to trust my local validation in order to build such an ensemble. And at the end, the ensembling based on a diversity of models and a diversity of combination of features provide a robust submission. However, you could build a much simpler model with a slightly lower score, as shown in the last slide. So this is my bibliography, and if you have any question, I am available at xavier.capdepon@gmail.com. Thank you.